neural networks, the fire of life, fury, a giant cheeseburger city floating in the sky, and a waste of space. All of these images were created, original works, by a computer. Now this is not some magical computer in the mountains. No, this is a computer right here, right now, and we are going to make some art together. So, what was the prompt? Come on, anything. Life, death, the meaning of kangaroos. Literally any sentence.
Meaning of
Anybody.
kangaroos.
The meaning of kangaroos?
Yes.
All right.
I don't know what that looks like.
Since before we go over the beautiful art we made together, let's talk a little bit about what's going on under the hood. So, neural networks are changing the world. The ever-present YouTube algorithm tells you what you want to watch. Cars and planes are going to be driven by them, and many, many other things. However, unlike some people would like you to believe, these are not some mystical creature that is unknown. In fact, they've been studied for well over 50 years and have a lot of really well understood things. Now, me myself, I've studied neural networks for several years. I've made several neural networks for myself. I consulted with Dr. John Shepard for this presentation. And in just a few months, I will be working for the U.S. Army Combat Capability Development Command Aviation Missile Center, long thing, to help protect you from missiles using machine learning, among other things. So, originally, neural networks are modeled after the brain. And similarly to the brain, they have a fundamental building block, similar to a neuron. This flows into a giant network of connections, and it trains or learns very similarly to how you and I learn. Now, as you can see, this is your brain, which has 100 billion neurons. Each neuron can have 10,000 connections to other neurons. And these are not little baby connections. The longest connection in your body runs all the way from your toe, and with a single cell goes up your body into your brain. Longest cell in your body. Now, how do these connections work? So if you see here, you have a synapse. Your signals come in from all these thousands of connections. They come in. Strong connections get amplified. Weak connections get opposite amplified. And they come in, they're adding together, and then at a certain point it reaches a threshold value, and it pushes, and the signal goes through to all the other neurons further down the chain. So, now, computers are not the brain. In fact, they're just trying to imitate the brain. Just like this person, who does not exist, is an imitation of human. So how can we convert this idea, this biological idea, into a more mathematical format? So here, you have all of your inputs. And how do we add them together? We add a bunch of numbers together. And the weights, strong connection, weak connection. A strong connection multiplied by a big number. A weak connection multiplied by a little number. Add them together, you have some sort of an activation function, which just tells the neuron or perceptron when it can activate, when it's time to push forward to the rest of the system. Now, all these systems, they're made from that simple basic neuron. And every circle you have here will be your individual neuron, and every arrow represents a connection to other sorts of neurons. And there's all sorts of shapes and sizes. Really short and fat ones are great at memorization. Skinny and narrow are great at improvisation. And there's a million and one ways that you could do this. Now, just like you and I, these things need to train. And for example, AlphaZero learned to play chess better than any human ever in 1 hour on a normal computer. So they learn a little bit differently than that. But training a neural network can also be somewhat entertaining, and you can really get a feel of a personality for them. So remember, they're modeled after the brain, and a lot of these models have sizes of brains similar to a mouse. And so, myself, I made a neural network that has missiles coming up, and there's missiles coming down, and they're trying to intercept it to save you from these little missiles. going through, and you can watch them. One time they'll miss, just barely. And the next time they'll come up with a new idea. They'll come in from the top. Somebody else will come in from the bottom and swing over. They have all these different ideas, and you feel like you can root for them. Which normally for a computer, just kind of does whatever. But these, they learn. Now, genetic algorithms, they learn, basically. You put 100 of them out there, 12 do pretty good. Everyone else dies. You take the 12, you duplicate it, you change it a little bit, you try it again. Whoever does the best moves on. Whoever doesn't dies. And that is how we learn. Reinforcement learning is maybe a little bit more familiar to you and I. And that's how the chess game works. And basically, if it wins, it gets rewarded. If it loses, it's punished. And it keeps going on, and they learn, they get better and better. Now, hopefully you have a little bit more of an understanding of the neural network, how it works, and how it can affect you in your everyday life. And it's really just a perceptron, or a neuron, combined into a gigantic network, which could be hundreds of billions of parameters large, plus an ungodly amount of training, and that is how this bear on its way to work was created. Now, before I get the art that we created, I'm going to leave you with a quote that I got talking to a computer. The purpose of change is to create new opportunities and experiences that can lead to growth and development. It is also a way to overcome challenges and obstacles in life. Change can be difficult, but it often is necessary in order to improve our lives.